All right. So in this meeting, we will talk about long paths and what we do, and Jeremy will walk us through the deck that he created. I will share the screen. Please make sure that if you have any questions, just add them to the Q&A panel, and I and some other people hopefully check sporadically and let us know when there are questions so that we can answer them. Let me know, share the screen. No, that's not the screen sharing button. That's the screen sharing button. And here we go. So you want me to take notes, or you just walk through the deck? And
sure.
Just let me know when I have to click the next button so we get to the next slide.
All right. So, today I just want to go over what we're planning to do as we start working on long path support. In particular, we have to do long paths in general, or more than 260, because now that we're cross-platform, nobody on Unix on any of flavor are going to be happy with 260 as their max. So we've definitely been doing work there already, and we want to do similar work along the Windows end of things as well. So the most pressing need right now is that we get our Unix stuff up to speed, is that we unblock all the places where we've had 260 hard-coded into the runtime and into CoreFX.
So wouldn't we have already handled this with Rota?
Right.
Wouldn't this be a matter of just, like, Rota, assuming we did this work for Rota?
I don't know. We've definitely done a lot of work already, so I don't know if I just graded over time or whatever.
I'm sure there was a lot of rut there. Yeah.
So, we're doing that work, and in parallel, we want to actually support greater than max path on Windows as well. And as I said, this is just to share the early thinking on it, and I plan to come back with deeper dives into API changes and particular issues that we run across and implementations around those issues. I'll talk briefly about my initial thinking around those things today. So the devil's in the details with this stuff, so I don't doubt that we'll continue to uncover lots of interesting side and corner cases with this. I've been dealing with the max path stuff for 10, 12 years in earnest, with writing a project system for expression, and while I know a lot, there's still a lot that I don't. So go ahead. And just seeing the way we're approaching this is, like, we're going to have to deal with the Unix stuff first. We have to make sure that the runtime is actually working with, like, the Unix paths, which are, on the Mac, for example, it's 1024, and Linux boxes, it's 496. As soon as that's all up to speed, we'll continue to work on the long path format for Windows. Coming up on the CoreFX stuff first, which means, being able to navigate files and directories, open streams, all that sort of thing. With a second priority, getting, assembly loading and resource loading working with long paths in the runtime. So I've actually, last week, I checked in a number of unblocks on the syntax for extended syntax for long paths. It still blocks at 260, but at least you can use the extended syntax now in most of the cases.
So that would, so that means that's behavior, like, when you use the extended syntax, you're now opting out of normalization, right?
Correct. I'll talk more about that.
Okay. Yeah.
So this is just to let you know, like, what's coming, and that's why, even though that stuff is, like, post getting the making sure that the runtime is fine with the long paths on Unix, there's a lot of design work and iteration that we're going to have to do around that stuff. So I wanted to start the discussion now, so people could start to be aware and also chime in on things. I'm going to talk really briefly about path restrictions. So one of the things I think is important to recognize is that, like, path lengths are not a function of the file system per se. So file systems will pretty much go until you run out of hard disk space. But the path lengths themselves are restricted by the OS. So it's an important distinction to remember. And it comes up with cross-plat work and stuff like that if you start like sharing things in between particular OSs. Path segment is another thing to think about here as well. Like that's the file or directory names themselves. There are restrictions on that vary. It's usually 255, but UDF is actually defined at 254.
What is UDF?
It's what you get with optical discs usually. So if you have like a rewritable DVD or
I see.
CD, that you'll get that format. I went and verified that as well, and those all do come back there, and the specs actually have it as that as well. So.
And that is like same as true on Linux and Unix, or is that the 1024?
That's the long path. So the path segment thing is true. Like the 255 is also true on Unix as well. So.
I see.
And with the UDF being.
Makes sense.
Now I may be missing particular file systems where this one is more of a file system limitation, and there's probably other file systems that are outside of the common ones that I'm missing.
Is the path segment just the file name, or is it any of the pieces in the segregated path piece?
The full file name or directory name, in Windows that includes the extension.
But not the trailing slashes.
That's already live. Must be you.
So
anything between slashes, that's the limit, right?
yes, yeah, in between directory separators. I mean, Windows APIs and tools have compatibility restrictions around. I mean, internally they handle long paths, and we're talking about that, of course, in here. In Windows it's actually 32,000 characters.
Mm-hmm.
But most of the choke points in Windows in the shell and in the command console are choked at 260. And they also do normalization, which is the thing we talked about. So there's certain characters that you can't use that are meant for backward compatibility. You can't do a trailing period on your file name. You can't do trailing spaces, that sort of thing. At the very end. So you can't have foo space. You can have foo space.txt or something like that. So there's a lot of corner cases with that stuff, and we have rather extensive parsing code in .NET to validate the paths are legitimate or not. Device names are another thing too, where technically those are legitimate, but the OS tries very hard to keep you from doing that. Just some background there, but go ahead and go on. Windows provided an extended path syntax to get around the long path issues and the compatibility issues as well. It encapsulates two things, and that's actually an issue for us. But if you don't know, the extended path syntax is you put \, \, / in front of your path names, and they allows you to get at that full 32K limit. It is approximate. It's it's a short worth of characters, but the path has to fit once it gets transformed internally in the OS. So your C colon will become something else, right? So they don't document exactly what it is because they have to tell you exactly what's going to happen, and that's dependent on device drivers and everything else that you have on the machine as well. But that's way, way beyond what anybody else has anyway. So it's just important to note.
What a good way to think about this is that Win32 is the one that does things like normalization and stuff. And
It does. So if the paths come in, and this is the thing that extended path syntax does, and they say at the end it doesn't normalize at all.
Yeah.
It takes paths exactly as they are. They have to be full. They can't be relative. So it has to be C colon \.
So when you get these paths, Win32 says hands off. I'm not even going to look at this. I'll just pass this through.
It won't normalize it. It will block some things, right? Like you can't have any. It'll fail eventually. Like you can't have a file name called dot in Windows.
But Win32 is just a pass through, right? It, as in, like Win32 passes on to further down the track, down to some, additional APIs of the file system itself. And
Correct. It gets, everything ultimately gets converted into an NTPAP, an internal NTPAP. In the legacy scenario, it does a lot of normalization and combining that with the current working directory, that sort of stuff, before it actually gets to the next level. This just passes through. There are still invalid paths, or invalid characters are still the same, like as far as like characters you can never use, like the asterisks and things like that. But and then there are a few reserved things that are just impossible. You cannot name a segment, period, or double period in any of them. So, but here, like all the other sorts of things, like the trailing spaces and periods, and like you want to name your file con, you're more than welcome to. That'll confuse the heck out of some things, but it is possible. So that's it for that. So Unix is pretty straightforward. We just need to like find places where their path syntax is not anywhere near as complicated, and that's more of a mechanism of just making sure we're not blocked to 260. So I'm not going to talk much about that. It's not really that interesting. The more interesting thing is
if checksum will be aggressively, will be just aggressively constrained for no reason. Right? It's basically
exactly. So the Windows part is the more complicated. The goals that I have in mind are like that is a few of these are the major goals. It's like you want to allow long paths without extended syntax to just work. So you give a path, if it's 270, 280, 300, it doesn't matter, right? The framework will take care of that for you. And there's a variety of reasons for that. One of the things is that facilitates writing your programs cross-plat. You don't have to do anything special to support long paths on Windows. But the second thing, which is also incredibly important, is it allows legacy normalization, right? Which is it gives you better legacy support, right? So taking out trailing spaces and those sorts of things is good mojo for compatibility in general.
So that's going to be, we'd have to basically re-implement what Win32 does, right? With all the rules.
Which we already have.
We haven't. We don't handle things like d::foo text. What text means get me the current foo.text from current directory on D. We don't handle that, for example. So there's some kind of.
So there's combining of the paths. We already do some of this, and I'll talk a bit about that as well. So like the resolving against a base path, there is work we have to do in there, but it's relatively simple. It's just you just have to combine it against the proper root. So like you are bringing up a lesser known case is that so you can have drive relative paths, which most people don't even know that you can do that.
They don't know, but
they accidentally hit it a lot.
Well, yeah, they know. They hit it all the time. Yeah, I do. I hit it myself too. Writing a project system. Yes, you hit it in spades.
Yeah.
People are always hitting this. So it's not terribly complicated to do. The syntax is pretty straightforward. You just have to slap it across whatever the current working directory is on the other one.
So just to get this right, so basically what you're proposing is that our API still accept the paths without the prefix, and then when we call Windows, you would just prefix it with the extended syntax, do the gymnastics to convert relative paths to full paths, do the things of d::blah, get the current directory, expand this, and then when we call Windows, we just did all the magic to make the paths basically just be working, right?
Yeah, and it's a lot of the more complicated things as far as dealing with relative paths and that sort of thing. We already do a fair amount of normalization there anyway. And Windows is more than happy to get long paths in the old syntax when you're doing the get full path for Windows, right? So it doesn't need extended syntax for that as well. This is something that I've actually done and implemented in the Blend project system, for example, was taking long paths and that had lots of relative segments in them that were way over 260, right? That ended up being under 260, giving it Windows the opportunity to concatenate it down to where I could then pass it to the framework. So it is possible, and it's not terribly hard to do either. And we also want to allow the extended syntax period on the Windows side of it. That will allow people to deal with scenarios that you just cannot deal with now. Like if you get in a foo space in a file, you're stuck without writing your own pbooks and dealing with it yourself. So for people that are intending to write utility code or whatever, and they need to get to that level, they're going to be able to. And having that support internally helps as well. One of the things I actually changed and fixed is like when you do a directory delete, it will actually work now if you have a file or a directory name under it that has like a period or whatever. Because all I do is internally, since it's an internal iteration, I just put the extended prefix on it, and that works fine now, for example. There'll be a lot of other opportunities like that as well, where stuff that didn't work before will work because we made sure that we've supported the syntax through. So,
So like what happens in general, like when I get my hands on the path of an extended syntax, can I paste this in Windows Explorer? Will that work? Or is it something that is like...
The shell I haven't tried with the extended syntax. Command console does work. One of the things hopefully that will come out of this relatively shortly too is that we'll have like a PowerShell that will, like certainly on .NET Core, that will work with it. And eventually, hopefully, we'll be able to port the stuff back to the desktop and at the very least get PowerShell up and working soon.
Yeah.
And hopefully that as we continue to make progress here, that Windows will be unblocking some of these scenarios as well, right? So it's not a technical problem for a lot of these things. It's more of a resourcing issue, but it's becoming more and more of a problem as cross-plat becomes more and more important. Various teams, even within Microsoft, are hitting this in spades. Like OneDrive, for example, it's like, well, geez, I'm like trying to sync up folders between Mac and Windows. I can't take these file names from one to the other, right? So it gets ratcheted up further and further and further as we're going along. Drive spaces are getting larger, and just much easier. We hit it in spades, like trying to do projects and things like that. You start generating files and like, okay, that's stuff we were hitting 10 years ago all the time, but now users are hitting it more and more.
So what I see we're doing is we're basically saying, okay, we'll unblock our part of the stack.
Yep.
And like no longer will .NET be a preventer of long paths.
Correct.
And things that fall out downstream, like we just have to keep pushing on that.
Yeah. And hopefully some of the things that we can do, like as Windows support comes on, whenever that happens to be, one can assert will probably happen eventually, hopefully sooner rather than later, as things are changing. But we can continue to tweak the framework to like stop doing some of the extra work that we're doing on as support comes online in Windows anyway for dealing with this. So and the last thing is I want to facilitate writing path code that works. Right, this stuff is complicated, and it's very easy to write code that just is broken when you're comparing paths.
Yeah, so
on Windows in particular.
Yeah, so what I should be able to write path code that's agnostic.
Exactly.
Yeah.
So you don't have to think about Windows at all, and your things will just work for you. And there's only a few core pieces where that's a problem, and I talked briefly about that as well. So I'll talk a little bit more about the details with this. There's some big issues out there. The biggest one in Windows at the moment is that the current working directory cannot be over 260 characters. That I don't know precisely why that's the case. I still have to talk with the Windows folks about that as to like why that's difficult to move. I do know that this stuff is stored within as environment variables, right? So it's in the process environment block, and I'm sure that has a lot to do with it. Beyond just compatibility with DOS stuff, and the command line, things, command shell. And I have some new path APIs that I have proposed that will mitigate this. In general, anyway, setting a current working directory is kind of bad news anyway, because it is a process-wide thing, and anybody that's actually dealt with paths in general will know that this just breaks. Matter of fact, I the project system in Blend, I actually had to like completely not do this at all. I ever had write code that did all this sorts of things that we're talking about doing here because inevitably some other thread would kick up and change the working directory and people's projects would crash, right? Because like your relative paths are pointing somewhere else.
Shared mutable state, always a good idea.
Yeah. So while this can be mitigated, it's actually a good thing in multiple ways, and that's really the point, right? So like if we have APIs for this that allow people to stop using the current working directory to get relative paths resolved, that's probably a good thing overall. Complicated is, iterating, querying paths that like require extended syntax. What the heck does that mean? What do we do in those cases? Sometimes it's simple, like if it's all internal, who cares, right? Like the directory delete thing that I talked about.
What do you mean by that? Like, is this path rooted, or?
Well, no, it's more of this path is foo space.
Directory.get files with your return.
So
As an invalid.
when you don't return extended syntax, what does that mean, right? Like what do we do now? Do we do what do we do in those cases, right? Like right now there's some of these things will fail, the other ones will like give the wrong path. I don't, like can we come up with a kind of a normalized behavior for these things? Is it okay to pass back an extended syntax in that case? What does that mean? If you're just getting file name as opposed to full path, right? There's a lot of like subtleties there that we'll have to think about.
I hope that we would never output the prefix.
Well,
Like,
the initial gut reaction is no, don't do that. But like these are the sorts of questions that we need to deal with. Now, hopefully, that's part of why I want to support the non-extended syntax for long paths anyway, because this kind of avoids getting into that which we want to encourage, really. And that's like sort of an encouragement of that. If extended syntax is our only method of getting long paths, then that starts allowing people to inadvertently add space and that sort of thing as well, not intentionally, right? So.
Well, that's a good point. Like, if you only allow extended syntax, and you go and do a query, or you only allow the prefix, you go and query, and that you get a path that's longer than that, and you go and pass that back to the file system. We're going to blow up. So
there's lots of reasons why like allowing a natural syntax makes sense. And one would think that like Windows would do it as well, because there's no technical reason why you can't, right? Other than it's like max path is hard coded everywhere, and that just takes time to take it out. And there's app compatibility things and that stuff as well. So I'm sure that's something they can deal with as well, in their normal compatibility shims and stuff.
Is this really only about the syntax that you posit, or do you have to call different APIs to the layer?
It's the same API always.
I see. So then people have existing code and they just literally pass it to their own P invokes that actually should probably just work. It's just about the assumptions you make about the pages that are in that stream.
Other than like buffer sizes and things like that too, like your querying and stuff like that, people are not dealing with the return values to put a bigger buffer in and that sort of thing. And then, backporting to the CLR the desktop CLR is going to be complicated and not straightforward. There are things like we run in full trust. This is one of the issues brought up in Kim Hamilton things. Is like, we have the file IO permissions on the desktop, which we don't have in the core CLR and stuff like that. Those are things we're going to have to deal with. In order to bring it back, and compatibility becomes even more of an issue. We need to put opt-in, opt-out things and that sort of stuff. So
yeah, I understand the issues of backporting into the CLR. I think that if we would not do it at all, I think the value would not necessarily disappear, but would be significantly hindered, right? Because if you look at the not Stack Overflow, but the user voice items, people hit this all the time, are cases like, I built my project on a build server, my repo structure is a bit nested, and then on my build machine, by the time TFS checks it out, the tabs are already pretty deep in, and I can no longer build, right? And so that, like, most of the tools that run in that context, like all the build tools, they're almost always desktop apps. So that basically means if we don't port it to the desktop, either we would have an additional support library that everybody would have to use, which may actually take even longer to actually get the build tool chain to fix, or we would do something targeted in the CLR, or the desktop memory would say, yeah, you can only use this particular mode if you're not running in partial trust or something else. But I think that one of the major value adds would have been that we could say, at least when you're like I think people are more likely to hit the development scenarios than they are for end user scenarios, right? I mean,
Correct.
my mom probably never hit MaxPath,
Well,
but I think the majority of devs at some point hit it because of the way things are being checked out.
they're the first ones to hit it, and I alluded to that earlier. But like your mom is going to start hitting it now too. Particularly as they start using their OneDrives and whatever else.
Yep, that's true.
As they're getting used to this, they're starting to like, well, all right, I need to back up my stuff. I know that's a good thing now. I need to put it on my OneDrive stuff, and like I start adding folder after folder after folder. Photos. Like you suddenly have tens of thousands of photos which you didn't have before. Videos, and people love to name things and rearrange them, and whoops, I can't do it, right? So, and that already happens now when you're doing the OS thing I talked about. You have OneDrive and you're sharing you're doing it on Mac and on Windows as well.
That makes sense.
So I think it's going to be dialed up. I absolutely think that it's super valuable and we need to do it. The point here is just that it has got additional issues, and it's not a simple just port things back.
Some of the mission changes that we made in 4 or 5 might help make this easier. Like full trust, we could just. I think we bypassed the permission stuff now. Full trust. So
there were. I assume it's going to be some sort of extra caveats and a few extra feature changes that we're going to have to do when we go back as well. So the design may need to change a little bit. Trying to whatever we do here in .NET Core, want to do it thinking of ultimately we want to put it back there and not arbitrarily make decisions that are going to make it really hard for us. So.
We just got a question, and I'm not entirely sure I understand it, but let me ask it anyways. Sorry, maybe I misheard, but is there not a way we can query Windows and have it handle the long paths under the hood using any APIs it exposes to us and not use what the shell uses? I understand at this point it wouldn't be applied on cross-plat. I guess the question is, isn't it just a matter of calling
it's not the shell. So we don't call
APIs.
the shell, we call Win32.
Yeah.
And Win32 does allow long paths, but you have to prefix it.
And that also means if I call create file and my path is relative or has ... in it, then create file will take care of normalization.
It normally takes, but if you use the prefix, then hands off on normalization. There's no normalization. There's no relative.
Yeah, so that path will fail in a particular case because it's not SQL.
So no, there's nothing in Windows that will allow us to just bypass it, just to make this magically work.
And I guess there's also no API we can say, take this path, normalize it, and you can fix just the result or anything like that, right?
There is sort of, and that's we just need the Windows, the Windows path that gives you the full path will allow you to pass in whatever string you want. I mean, there's no length limitation on that. So you can just combine the root path with the relative path, pass it to that, and then actually have it shrink it down to whatever it's actually going to be, even if it's over 260. But that code is not that complicated either. One way or another, we can deal with it on our end of it. So that's one of the suggestions I have coming up here. So and we'll get into the details. I just want to put those out there before we get into a little bit more of the details of what we're in the initial proposals are. So we can go ahead and move forward. Like I said, I want long paths to just work. You want to do the normalization past 260. That's legacy resolution, the double dot stuff, and character support, which matching the existing behavior, which is to trim off trailing spaces and stuff like that. It's never going to give you back extended syntax.
Does Win32 return the extended the prefix? Does it?
In some cases, I've seen that. I don't have an exhaustive list of that yet. It's because it's a pretty big matrix, but
yeah.
The general plan is just to intercept before we keep both. We've been having to force everything down to a layer anyway, which makes this a little bit easier in the .NET Core stuff. But we'll append the extended if we need it, and then trim it on the way back.
Fixing the relative path problem though seems kind of difficult because we're going to be fixing relative paths for files that don't exist.
it's still, you still have a root, right? And you still have
Right,
directory
but
segments, and it's just a matter of removing or not removing directory segments. So,
I
I
guess-
mean, that's Windows, it's just string manipulation. There is nothing to do with file existence.
Well, it will though, won't it? Because the file that exists is always off the current directory. The current directory.
Yeah, there's no.
I mean, it always ends up taking a relative path and making it a full path in one way or another. So like it's that part of it, that the dot thing is all string manipulation, even inside Windows.
One decision we have to think about here is that the CLR itself will have to do similar behavior. Right?
Yeah, and I have a couple API things that I'm talking about here to like help facilitate this as well for users as well. I mean, it's just exposing some of this. It's not horribly complicated, as I said earlier.
What I meant was that if we normalize, so does CLR has to normalize as well.
Hmm?
If we normalize, so the CLR has to normalize as well.
Yes, for assembly and resource loading.
Yeah.
Holy shit.
So,
What's the next
yeah,
one?
good. Go ahead.
Yep.
We've been talking about some of this. And the other thing was allowing the extended syntax. Some of this is already in there, right? It's like, well, when the extended syntax comes in, we don't normalize it. We just do what Windows does. And that's what we're doing now. I actually enabled this, and there's very basic correctness checks, which just says like to fit this sort of general, when you do path get full path, right? That like we kick out things that we know are obviously bad, right? So there are a few basic ones here that would kick out things like if you have a segment that's period or double period and invalid characters, that sort of stuff.
So I'm confused whether if you say allow extended syntax, that means the customer can also pass in the extended syntax, in which case we just don't do anything with that. Is that what you mean by that? Or
Well, we don't do any normalization. We do some basic correctness checks, just like we do with the other paths, but that's it. And the idea is that we only throw the path too long if it's over a full short. Because like we don't know exactly what the expansion and contraction is going to be in Windows. So like
Shouldn't we just let them throw that?
exactly, that's what I'm saying. Like if it's over that, like we know for sure it's going to die, right? And that will fit in our kind of expected behavior, our legacy behavior, which is like we try to do a whole bunch of checking before we at the path get full path level, and like that's kind of the happy medium. I don't want to allow it. There's also something about leaking in like gigabyte file names and things like that, which is probably nice that we do a little bit there, but I don't want it to get any more complicated than that for sure. Like trying to second guess it, like, oh, we'll do it 3 characters less because we know that it's going to be this or that.
Yeah, no, I looked at this 5 years ago, and yeah, you can't guess it.
That's my assertion. Like, we definitely know anything more greater than this will fail. There's no matter what, but like, fine.
We just have to make sure that the right thing comes out, like that it is path to it, right?
Yeah.
And not some IO exception.
Yeah, we'll have to find those particular
Right.
cases. Like I told you already, at least I'm blocking the syntax is in there already in CoreFX, and I just have not modified the path length check yet. So, and I'm starting on looking at the core CLR pieces for Unix in particular, but also looking at the extended syntax there, so getting the longer paths all the way through in both systems. So long strings is the priority first to make sure that we're unblocked. But that's it for that. And this is all very preliminary. I just kind of pulled names out of my
sure.
to start, but the big thing is like in path get full path is what are the changes happening there? Like, well, or it's like this, like normal paths allow greater than 260 and we normalize them the way we would expect to. And that should mostly just work just the way the Windows works already, with combining 2 pieces together and that sort of thing. But trailing white space, trim, separators are the things that we do. Separators are collapsed and normalized. We do some normalization of periods and reject certain paths, or certain combinations of periods and spaces. It's really a lot of nested code in there. It's short file paths are expanded. This sort of stuff is done. And sort of ready. This is already in here that the extended paths are validated and not resolved. And the suggestion I'm adding is that we add a new overload in here where you can like pass in two strings where you're defining whatever the root path is supposed to be and what the relative path is, and allow us to consider that your current working directory.
I had a similar proposal about a year ago.
And like I said, I actually implemented this sort of thing in the Blend project, the legacy Blend project system that used to be around, but to deal with things. And the assumption will be is that always, and this will allow people also to work with extended syntax as well. If you pass up extended syntax as the first part, is that we will treat the second part as relative and combine those things together to get the dot stuff happening, right? And then pass it through. And this is what allows it to get around the current working directory limitations, at least some of them. It gets more complicated when you're talking about drive root and stuff, and those are some things we have to like drill into as far as like our behavior there. Because you can't say D: without a backslash, and it says whatever the current working directory was last on D if you happen to set one. And we can use what's currently in there, but then you're stuck with not having one that's over, and that may be okay, but like we just need to at least drill into it and make sure that we're considering that.
So for this new overload, if you pass it as the first root path, you pass it extended syntax, and this is the second one, we have the relative path that would basically eat up into the root path.
Yeah.
Would we do all that normalization?
Yeah, that part of it, I mean. So only that's like just the dot and dot segments we will pull out or leave, one way or another. We like either remove a segment because it's a dot, or just remove the dot because it means nothing, right?
And then the extended path
like,
cannot have the dot and dot, right? They don't have.
Yeah, the root path can if you have it as extended to begin with, but so we won't.
Well, we're missing something really fundamental. But how is this overload different from just path.combine? Where
Path.combine doesn't do any normalization. It just adds a directory separator.
Get full path really means normalize this path.
so we leave the dots
Root it.
in essentially, even after the combine. And that's right.
Path combine, but
Path.combine.
Path combine is very naive. All it does is just
It puts a directory separator if there isn't one.
Makes sense.
that's effectively it. Get full path does a full normalization of the all the dots disappear.
Yep.
And I said that we'll keep the extended characters in the root path and in the relative path if the original path is extended. And that'll allow people to deal with something that's a little hard to deal with now. But and that for further clarification, like I said, if there's dots and dots in the root path and it's extended, we won't mess with them there. We don't mess with them in the second path. So that's the contract, is that that relative path is relative, and if you have dots or dots in there, they're intended to be relative. Now it's already it'll get kicked anyway for a dot or a dot, but we're not going to worry about that in what you consider the root path.
So, but that overload is conceptually the same as calling get full path of path.combine of root path relative path, right?
So what it's really kind of equivalent of is the current working directory actually could be set to anything.
Mm-hmm.
Is that it would be the equivalent of setting the current working directory to whatever the root path is, trimming off the first part of it. I mean, you can't do it it's not going well. If there was no, let's take extended syntax out because it's simpler, right? It'd be setting the current working directory to whatever, and then calling the OS get full path on relative path, and calling path get full path to do normalization or throw out stuff that we do. The extended syntax is a little weirder, right? Because there is no normalization there on the there's no current working directory for that because it always has to be a full path, right? So they don't have a way of passing a relative path up against and their core things can't be that long anyway. Dealing with the extended syntax on the root path is just is an extra nicety for us to be able to allow people to deal with that. We know we have this relative path, we need to combine it with this other thing. They can always do it, right?
But if your root path has extended syntax, blah blah blah, at the end has invalid characters back dot or something, right? It would fail.
It'll fail when you cal path get full path. Yeah.
But what I asked before was if you have that and you have a relative path that starts with dot, right? Are we gonna combine the two and then basically the first dot on relative path would
go by segments, right? So it's a string manipulation for segment.
So we would go, but then we would go into the root path and get rid of that. Okay, so we would,
We move up a directory segment in the root path, no matter
so
what.
we have to process and parse the root path anyway for us to be able to do
Only
this.
from a directory separated perspective. I mean, we're still going to call path get full path on that first path. So if you have invalid stuff in there, it will fail.
Well, not necessarily, because they could have invalid paths there that get eaten up by the relative thing.
True.
Right.
They
That's-
could, but.
They could, but I don't think we need to allow
Why
that.
would we allow that?
But that would happen, right? If your root path ends with like blah 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 dot dot.
My suggestion is actually that,
you would have to go up
Well,
one level into the
well,
segment
we would
path.
call path get full path on the root path and like, or path dot normalize is what it is. It ends up being internally, and that will fail and throw at that point because you've got something that, like, as far as our like extensing as we know is absolutely not going to pass muster with the OS. Now there are other things that, like, because we don't like overanalyze too much. I mean, even on the non-extend syntax, I'm sure there are cases where we slip through things that are just not going to be allowed, but we're probably going to slip more through in the other case because like we're trying to match more of what the OS does, and you may end up in circumstances like that where like you are invalid until you pass a relative path to it and you can mind it.
So we're gonna validate the root path, then we're gonna look at the relative paths, assume, see if we have any wonky characters, and then we're gonna take the first path, try and
I don't think we have to look at any wonky characters. We can do that as a post step. But we'll just look at the.
I meant, sorry, by wonky characters I meant dot dot and backslash in the relative path, so we could try and apply it back to the root path. And the root path is something we normalize and we don't call the OS for.
No. Well, we do.
Eventually.
We call the OS like short path expansion. I mean, there's a lot of details into this, but yeah.
Okay.
A lot of it's in our hands.
Pay attention that path combine returns relative path if it's root.
Yeah, and the rooted, I didn't get into this part. There's more of the like these deeper discussions later. Rooted doesn't deal with like drive relative and stuff like that. It's there were some things to talk about there as well. But and also suggesting, and again, these were just had to pick up a name to start with, is that we add 2 more APIs to facilitate writing your code in a way that's not going to bust all over the place. One is like path contains, like, does this first path contain this other path? That's complicated even without extended syntax in there, so and easy to get wrong. And paths are equivalent. That's again another thing people get wrong too.
I don't know how we can answer that question. That very first statement: do both paths represent the same file?
It'll be caveated with what the normal thing is. Like there's even in the there's like you have links and all this other stuff. Like if you really want to go to say like this is physically the same, not the same file, we'll say it's the same path. That's actually probably a better way to word it. So the same file thing is that you have to get the final path right, and you actually get to know that right. In some cases, you don't even know that either.
It's an unanswerable question, though.
It is mostly unanswerable.
It's
Yes,
completely unanswerable.
well, if you take in UNC shares because you have no clue.
Well, I just need more of, by the time you access one file and then access the second file, it could have been deleted and recreated in between.
Correct.
But it's just talking about paths, not.
So yes.
But they don't refer to the file they used
Yes.
to.
Yeah, so
That's true, but the
so
paths
that's
have
what
to
I
be
said,
the
like,
same,
to
right?
clarify the wording would definitely
Okay.
be, it's not
Yeah,
really
yeah,
I think the same
really
file, it's
great.
just the same path, right?
Yeah.
Because like
Yeah,
right now,
yeah,
like
yeah.
right now, people will do like, well, I need to do in case insensitive, right? Well, okay, that's not true for Unix, and well, they'll set up a dictionary, right, and like use
Well, there's-
the insensitive string comparer,
But
right?
I was going to get to that with path compare. There is no right answer to that. Because it's definitely not as simple as Windows is insensitive, Unix is case sensitive, because Unix supports FAT. You can actually create paths on Linux. I did this as an experiment where portions of the paths are case sensitive and portions are not case sensitive. Because you can mount a FAT32 volume under an extension 3 file system. And so there is no case sensitivity across that is consistent across.
Yeah, this is why I want to have more design reviews, because he's bringing up valid points here, because it is very, no matter what you do, it's impossible to get 100% accurate. It's just, there's absolutely no way.
And Jared,
And
why don't you ask how many times we cache based on file path?
It's always wrong, and I keep finding more of them.
Yeah, but we do it
I know.
absolutely.
Well, everybody does it all the time too. You know, like this is to get into like more correct. And you know, this one in particular, like, is crazy with details on it. We don't have enough time to go into it here, but I will be going into it, and we'll be doing more design reviews around that too, to talk about all the things of what level of guarantee we're actually having here. And it's not really much of a guarantee. It's just like, look, you're not going to trip over yourself completely by like doing things, for example, like not dealing with the trailing directory separator, right? Because these are the sorts of things that people fall over in spades.
Well, one thing I was curious about, I was wondering that we would have found valuable in ROS, and then something we may still try to add later on, is do we have, it would be great if we had a method of, I'm going to give you a path, you give me back the canonical version of that path. Like, for instance, in Win3rd and NTFS, it's a case insensitive file system, but the file system is case preserving.
Yes.
If we gave it, if we had a way of saying, what do you think the path, like, I know this points to a file, you tell me.
A totally normalized.
Yeah, you
like,
just give
so
me-
there is an API in Windows now that actually gives you the final path, that actually does the
Yes.
case normalization and all that sort of thing. Now, I think we should be exposing that too, and a few other things. Now, the question is, how do we do this for Windows only? I mean, that thing only has any real relevance in Windows, right?
Right,
Or
I
like,
don't-
or what more
Yeah, I
of
don't
a
know
generic
if there is
cross-plat thing?
one for cross-plat.
What do you call that? I mean,
Yeah.
but that one in particular is interesting, because like my memory, like digging back on the, 2005 when I was first bashing my head up against these things, is that, the framework used to do the case stuff on it. Now, I may remember it incorrectly, but I was having issues, and I talked with Kim Hamilton way back about these things, because like here are the things I hit, and it was like, it was 2005, 2006. I talked to her, but I thought that was going to be a problem here, and I actually looked into that in some depth. So Windows itself has added that functionality, and it actually maintains that internally, which it never did before. You used to have to go through and find each file handle all the way up and get the actual path. So they've got a shortcut for that.
Right,
now.
right. And I, as you said, I don't know if there. I found that API when we were having the browsing problems, but I could not. I didn't spend a lot of time on the problem, but I could not find a general purpose one that we could use on like Linux and Mac, and so we haven't gone there yet. And we've chosen the way of just saying we'll treat everything as case sensitive, and if the user gives us different case paths in certain scenarios, it might validate our caching. But for now, that's kind of all we can do.
Mm-hmm.
Well, if it's caching is not too bad, because the worst thing that happens is a miss, right? But you can easily imagine cases where you need.
Well, the CLR is a perfect example. Wait, do we load this assembly again?
That's exactly where we cache it. It's
Right.
for our analyzer work. We have to kind of know.
On any of these strings will pop up in multiple places. You start iterating again, and like you're getting file names, it'll give you back the case normalized file name. But the first place you got it was a string. There was a relative path, and you just combine the thing, and then the case is different. I mean, it's very easy to fall into this, right? Particularly if you have user files or user specified file names and strings. That's where it's very easy to trip over this.
I'm wondering, does anyone else have APIs like this?
Like what?
Like just Java? Like other things that are...
Other frameworks?
Yeah.
I don't know. If you look for Path Compare, it's like in Microsoft code, everybody's implemented it.
Everyone. Yeah.
So like this sort of basic APIs are implemented all over the place, and and they're usually wrong, or more wrong than they need to be, given his information there. And it's that the tricky part about this is actually like what exactly, or how do we communicating this, and what does this encourage, or like what are the things that it's going to help with versus actually adversely impact people because they are expecting some sort of trust and misunderstanding exactly what that's going to be doing. And these are long conversations for those individual pieces, but the general argument there is that like things are really bad and people just go write it yourself because we don't want to guarantee anything, as opposed to like we'll take you up to a level. And there's the 80-20 versus 90-10 versus 99% of the time you're right.
Yeah, but I can just see the SDL picking up this and saying, "Oh, don't use these APIs," because people start using them for security decisions. So.
Java looks to have a compare to for paths.
So,
I think there's some comparisons in Node as well.
and there might be options for this too, like the normalization piece. Like I was actually thinking about this, like, like you can fire up different levels of assuredness, like the casing piece. It's hugely expensive to do the casing part. It's hugely expensive to do any of this anyway, right? It's like really trying to normalize these paths, but there might be opportunities to dial it up or dial it down. From a perf perspective, maybe we start with something that's like, then we'll go and get the right cases and stuff and like say like it's super secure, but like.
The final thinking we'd kind of come to on Roslyn was that no matter the case sensitivity of the file system, all are case preserving. We weren't aware, we could not find a case insensitive, non-case preserving file system. That just seems crazy. And that means I'm sure there's one out there. But we decided that was kind of crazy town and we weren't too interested in that. The way we kind of thought of it was that, like on the command line, we would normalize the paths and everything, all the APIs would just say we're going to do case sensitive comparisons. And it's the job of the callers to get the paths right.
And maybe that's where we start, like, and
expensive.
encourage that behavior, but allow people to like opt into something else or write their own.
So,
It
hold on.
is too expensive in the inside of our APIs to normalize at every step.
So so if I pass reference with lowercase r and reference with uppercase r on Windows, what does Roslyn do?
You're talking about the command line option, like, do you mean
Yeah,
the
like-
/r?
/r.
No, we're talking about file paths now. Like, I don't care, like, that's a command line option. We're saying that if you created a compilation from the command line perspective, it doesn't really do much. But like, let's say you created a compilation with like c.cs, and then you said like add file, uppercase c.cs, or replace file, we would treat it as two different files. Like, it's the job of the caller to make sense of the file system. Because there's no way for us to internally make sense.
You mean CSC will do the right thing? So,
Yeah, CSC does the right thing. We're saying internally in our APIs, how do we treat paths when we have to do things like compare file names? Like, we need to check for duplicate document names in our compilations. And we've just taken the approach of, we're going to do case sensitivity. And that's the only thing we can do. Because in a Unix world, even with the crazy things I've told you guys about, there's still just case sensitivity is the only same way to do it.
Now, this isn't the only problem here now too. We're talking extended versus non-extended, and that's one of the other things that comes in here as well. But
Looks like
we're not dive there right now because that will take us forever. But
looks like Linux, BSD, and OS X all have a real path C API that returns a canonicalized absolute path name for any path passed in, which might be useful for us to use.
Perfect. That's essentially what we would need.
Oh, that's great.
I did not find that.
So that may be another one on there as well that we end up like path, get canonical path or something like that.
And it works on everything that we look at.
Now, even with the Windows API, there are caveats on it. Links don't do it. So, or symbolic links use things.
This seems to work with symlinks. It's actually resolves symlinks.
Which one?
Real path on Linux BSD. The Linux
Oh,
API.
I love the Linux BSD.
Yeah,
Well,
Linux.
on the Windows side of it, there's NTFS is horribly complicated. There are lots of corner cases I'm sure we're going to run into.
All right. I think you're right. Out of time, you're out of slides.
Yep.
So what are the follow-ups here? Like, are you basically going to do a bit more of a detailed design, or?
Correct. For each of the pieces, and we'll circle back around. There's an issue open on GitHub around supporting long paths that you can like chime in on that. In the meantime, you're always welcome to communicate with us, me in particular, whatever, and we'll continue delving into these things and kicking more design reviews around details on these specific things. Just wanted to at least share the very early thinking here to get people's minds open up on what's going on, and hopefully pull people in that have the relevant information or feedback that will include these as we dig into the deeper pieces. So I have a lot of talking I need to do with the Windows folks as well too that may surface more issues as well, so that aren't obvious, which I'm sure there's plenty. And I would be shocked if I don't find anything more. Somebody's going to tell me that, like, oh, you haven't thought about this crazy scenario, and hopefully we can be able to gather enough of those that when we do the deeper, we dig some of the deeper things and we do the deeper reviews, will actually be fairly robust.
Cool. then I would just publish basically your deck, or would I just copy and paste it into Markdown and then
Sure.
upload the results.
Video up.
The video will be up as well because as soon as I hit stop, it automatically uploads it. All right, then nobody has to add anything. I'll just stop the broadcast. Thanks, guys.